Welcome to Lecture 2.9. We're going to discuss compound inequalities. So a compound inequality is two or more inequalities connected by the word or and. So the word and, or. So let's take an example. Graph the solution set for the compound inequality x is less than -1 or x is greater than or equal to 3. Okay. The first graph will show x is less than -1. So open circle everything to the left. X greater than or equal to 3, since it has equality, it's a solid circle. 3 and everything to the left. Since it's an or, either one of them can be true. So the compound solution set is both the smaller than -1, less than -1, as well as greater than and including 3. Let's try another example. Graph the solution set for the compound inequality x is greater than -2 and x is less than 3. So just to show you individually, x is greater than -2 is going to be an open circle and everything to the right. X is less than 3 is going to be an open circle and everything to the left. But it's an and, so both of these statements must be true for this solution set to hold. So our solution set is everything in between, because once you go off to the right, 4 is no longer a solution because it's not less than 3. 5 is not a solution, it's not less than 3. Likewise, -3 is not a solution because it's not greater than -2. So it's only in between. It's an and. All right, let's try another one step by step this time. So 2x minus 1 is greater than or equal to 3. First I need it to say x. So I'm going to add 1 to both sides. I have 2x is greater than or equal to 3. And then I'm going to divide by 2. So x is greater than or equal to 3/2. And for the second portion of the equation, I'm going to divide by -3 on both sides of the inequality. And because I'm dividing by a negative, I need to flip the sign. So it's and x is less than 4. Negative over a negative is a positive, and because we're divided by a negative, we flip the inequality sign. So let me graph these each individually. So x is greater than or equal to 3/2. So I'm just going to mark down 1/2, and let's say that's 1, let's say that's 2, and 3/2 is going to be 3/2 right here. It equals 3/2, so it is a solid circle, and it's everything greater than. Second portion of the problem, I have 0, 1, 2, 3, 4. X is less than 4. So it's an open circle and everything to the left. But when you put the two of them together, because it's an and, it's going to be everything in between. So 4, 3, 2, 1, I'm just labeling some. 3/2, and it is a solid circle, to 4, which is an open circle, and it's everything in between, would be our solution set for this equation. Sometimes compound inequalities are written all together. So there's a couple ways of looking at this problem. One is we treat it as one big unit. And if we treat it as one big unit, what I do to one side, I have to do to the other side. Okay? For example, if I add 1, I have to add 1 to the -3 as well as add 1 to the 9. If I'm going to divide by 2, I have to do it to the negative, then a -2 and the 10. Or you can break it apart into two different problems. If you don't like it all together, you can break it apart into -3 is less than or equal to 2x minus 1, and 2x minus 1 is less than or equal to 9, and then work the two separate problems separately. But let's try working with it all in one group. So I'm going to add 1 to all sides, and I'm left with -2 is less than or equal to 2x is less than or equal to 10. Now I'm going to divide each side by 2, and I'm left with -1 is less than or equal to x is less than or equal to 5. Right? But if we work them separately, we should get the same values. So I'm going to add 1, I'm left with -2 less than or equal to 2x, divide by 2, divide by 2, -1 is less than or equal to x. But that's not the only x I have to worry about. I have to worry about the 2x minus 1 is less than 9. So again, add 1 to both sides. 2x is less than or equal to 10. Divide by 2. X is less than or equal to 5. We get the same result, but it's nice and compact when you do it all at one time. So let's graph. I'll say this is 0, -1, -2, -3. That should be enough. 1, 2, 3, 4, 5, and 6. So what do we know? I'm going to go ahead and say -1 is less than or equal to x. Think about x is in the middle. So it's not going to be way far out to the right. It's not going to be way far out to the left. So x is going to be in the middle of these two. It's locked in. So -1 is less than or equal, and it is included, so it's a solid circle. And the top boundary is 5, and again that is included, and therefore it's everything in the middle is the solution set. Now you can graph them separately by, and if you don't quite see it, x is larger than or equal to -1. You can graph each of these separately, but your final solution set is going to be the solid dots on the -1 and 5 and everything in between. Okay, let's try one more problem. -8 is less than or equal to 7x minus 1 is less than or equal to 13. Now I'm not going to break it apart this time. I'm going to go ahead and work with it as a compound inequality. First thing I want to do, add 1 to all sides, leaving me with -7 is less than or equal to 7x is less than or equal to 14. Divide all sides to 7. And now our final solution is -1 is less than or equal to x is less than or equal to 2. Again, going to put enough information on my number line. That's about good enough, because I only need to go from -1, which is inclusive, all the way to 2, and then everything in between. Sometimes you might have an and they're both going the opposite direction and nothing intercedes. Well, then no valid points go towards either one. So it is, what we can call it is a DNE, does not exist. So the solution set to the problem would not exist. Now all of the ones that I have provided examples for, those solution sets do fit. So that's it for this lecture. So until next time, be seeing you.